Hello everyone, my name is Gaurav Kumar and I had completed my MTech from IIT Delhi. Today we are discussing about some questions related to power system analysis, and in the power system analysis the fault analysis questions are mostly asked. Okay, so these are the first question. So first pause this video and solve by your own and then see the solution. Okay, so given that Z bus is given, so question asks that neglecting pre-fault load condition, the voltage at bus 1 during the voltage. So he asked about V1. Okay, he asked about V1 and given that what is given, ZF J 0.07 per unit is given. Okay, and pre-voltage B pre-fault equal to 1 per unit given. Okay, you can see that voltage neglecting pre-fault voltage condition, so we can assume P volt is 1 per unit. Okay, so if is equal to fault current is equal to B pre-fault, okay, divided by Z22 plus ZF. Why we are take this? Because we take because of property of Z bus, IF is equal to Thevenin's voltage divided by Thevenin's impedance. That's why we take this. Okay, so IF equal to 1 divided by Z22 is what? Z22 means 0.093. Okay, so J 0.093 plus J 0.007. Fault impedance is given at 0.007. That's why I write like that. Okay, so IF equal to 1 by J 0.1. So we can write like that, minus J 10 per unit. When the denominator J will come to the numerator, so minus J, that's why minus J, and 0.1 by 0.1 is 10. Okay, if you cross this and this plus. Okay, so that's why I didn't like that. Now question are asked that what is the voltage at V1. Okay, so V1 is equal to Z11 I1 plus Z12 I2 plus Z13 I3. Okay, so in these questions I1 equal to 0 and I3 equal to also 0. Why I3 and I1 equal to 0? Because symmetric fault occurs at bus 2. Okay, so that's why I2 is there, but I2 is there. I2 is equal to fault current. We can also write like that, I2 equal to IF. Okay, so now B1 equal to Z12 I2, and we can also write like that because of pre-fault condition. So B pre-fault minus Z12 I2. Okay, so B1 equal to 1 minus J 0.061 into minus J10. So we can write like that, B1 equal to 0.39 per unit is the answer of the questions. Okay, why we didn't like B per unit default voltage? Because in the given condition of the bus impedance matrix, the criteria of B1 is B1 is equal to B per default minus Z12 into I2. So B per unit is given at 1 per unit and Z12 is given at Z12 is 0.061. This is Z11, Z12, Z13. Similarly, Z21, Z22, Z23. Okay, so the Z31, Z32 and Z33. So Z12 is given and I2 we can find in the earlier Z minus J10. So if you solve this, then B is equal to 0.39 per unit is the answer of this questions. Come to the next questions. Given that the valid question I asked about the valid positive, negative and zero sequence impedance for a 220 kilovolt fully transposed three-phase transmission line from the given choice are positive, negative and fully transposed three-phase transmission line. So we can write like for three-phase fully transported transmission line sorry, 1 second. Condition is x1 equal to x2, x1 is approximately equal to x2 less than x0. Okay, so see in the options which option is based on this x1 is equal to x2 is less than x0. Okay, so in the given firstly positive and negative and then zero sequence impedance given. So this is the positive, negative and then zero sequence impedance. Okay, so in the given option x1 equal to x2 equal to 0.15 and x0 equal to 0.35, these options are based on option B. So 0.15 x1 equal to x2 means positive sequence impedance is equal to negative sequence impedance is less than zero sequence impedance. So these criteria are matched with option B. So option B is the correct answer of these questions. Come to the next question. In these questions, given that a series impedance matrix is given and the positive sequence impedance are given that 1 plus j10 and the zero sequence impedance are 4 plus j31, then the imaginary part of Zm. Ask about the imaginary part of Zm. So the concept is for the impedance matrix Zs plus 2Zm, okay, 0 0, Zs minus Zm 0 0 0, Zs minus Zm. Okay, so we can write like that Z naught equal to Zs plus 2Zm and Z1 equal to Zs minus Zm. Okay, and similarly Z2 equal to Zs minus Zm. These are the concept based on the impedance matrix. Okay, so in the given that positive sequence impedance is there, positive sequence means Z1 is there and zero sequence impedance is Z0 is there. So Z0 4 plus J31 equal to Zs plus 2Zm and positive sequence impedance is given 1 plus J10 equal to Zs minus Zm. Okay, so if you calculate this, what is asked? If you subtract these are the equation first and these are the equation second. If you subtract this, so 4 minus 1 is 3, this is the minus, so 31 minus 10 is J21. Okay, and Zs and plus Zs and minus Zs cancel each other and these are the plus sign. So 2Zm plus Zm is 3Zm. Okay, so the question I asked about what is the imaginary part of Zm. So imaginary part of Zm is 3Zm equal to J21. So Zm equal to 3 7 ja 21. So 7. So 7 is the answer of this questions. Imaginary part is 7. Okay. If this video is helpful for you, then please like and subscribe my channels and